Hello, my name's Fiona Marshall and I'm a PhD student at Ulster University. My research explores the use of video to automatically detect agitation in people living with dementia. We aim to create a system to supplement existing care by monitoring the frequency and intensity of agitated episodes. In this study, we explored whether repetitive hand movements can be recognised from video. To date, most research has focused on the use of accelerometers. However, video cameras are unobtrusive, widely available, and provide data rich for analysis. We created a video dataset of 5 repetitive hand movements: clapping, picking, rubbing an object, scratching, and wringing hands. 15 healthy participants repeated each movement at 4 different speeds for 6 seconds. Using open pose, we converted each image into a stick man, simplifying calculations whilst protecting privacy by not retaining images. Each frame was pre-processed to create a scale-normalized skeleton hand and arm pose invariant to participant size and distance from the camera. Classification of movements can be complex due to the need to consider both spatial and temporal information. The simplest approach to recognizing movement is to reduce each sequence to a single feature vector and apply a classifier such as a support vector machine. However, vital information may be lost in the data reduction process. Recurrent neural networks are widely used but can require lots of training data. A less data-intensive method is naive Bayes' nearest neighbour, which measures the similarity between frames and sequences without considering temporal order. Reducing a sequence of skeletal poses to a single mean pose is a simple but effective way to classify repetitive movements. We use the mean position of each joint over all frames of the sequence. Cross-subject classification of sequences represented by a single mean pose with SVM achieved an accuracy of 63%, suggesting that this is an efficient and accurate way to represent repetitive movements. We compared our results with those from LSTM's and naive Bayes' nearest neighbour with all frames. Naive Bayes' nearest neighbour obtained the highest accuracy. Unfortunately, this approach is very slow as it requires searching every frame of the training data to find the closest example for every frame of the unknown sequence. However, the high levels of accuracy achieved suggest that sequential order may not be as important for recognizing repetitive movement as for other activities. Building upon the effectiveness of the mean pose, we add additional information from each sequence: the poses where the hands are both furthest apart and closest together. This gives information about the range of movement in the sequence. Separating each sequence into 3 sub-sequences gives us a total of 9 discriminate poses for each sequence. We use cross-validation to test our approach. With random 4-fold cross-validation, naive Bayes' nearest neighbour with discriminate poses achieved nearly 99% accuracy, demonstrating that it can distinguish between repetitive hand movements. You'll notice that the main areas of confusion are between scratch and pick, which can be very similar movements. For the second test, the data was split so that the test data contained movements at different speeds to the training data. This time, 98% accuracy was achieved. For cross-subject testing, overall accuracy fell, with individual folds ranging from between 51% and 91% accuracy, reflecting inter-subject variation in how the movements were carried out. Finally, we removed first scratch and then pick to discover the effects of similar actions. Accuracy rose in both cases. We've demonstrated an efficient method for accurately recognizing repetitive hand movements for known subjects from video. Discriminate poses provide an effective summary of repetitive movements by ignoring uninformative frames whilst capturing the key patterns of pose and motion. Our approach works well for known subjects and generalizes for different speeds of movement. We're now building on this work, exploring methods to measure the intensity of repetitive movements. Thank you for your attention.